Hi, this is it. It's just the four of us. This is financial mathematics. I'm Dr. Sassmore. Those of you that had me before, welcome back. New ones, hi. Um, my office hours are immediately after this class, Monday, Wednesday, Friday, 10 o'clock in the morning. Thursday after this class, and again in the afternoon, I'm over in Reeves in the Enrichment Center next to IT. If you've not been there, that's fine. The phone number, if you want to call me, just let me know. I'll help you get there. Um, we're going to cover a lot of this. This is one of the exam manuals for the actuary exam, for the FM exam. I think it's really a matter of learning the symbols and the steps that the actuary exam prefer. I believe I've requested a print version of this as opposed to an e-version. So you might not be able to get it through Canvas, but if you're part of the book bundle, it's in the bookstore waiting for you. We're going to use it a lot. Please have it on hand. Um, I think we'll get through all of chapters, first 7 chapters. Maybe we'll get into that one topic in chapter 9 that I've listed in the schedule. There's a bunch of stuff from the actuary companies that is provided to us that includes on our Canvas page. There's a formula sheet from the Actuary Society. It's 4 pages front and back. This one down here, exam FM formula sheet. You should print that. You should have a copy, download it, annotate it all you want. I want you to be able to use that. That's going to be very helpful. A lot of what we do is also available as part of the financial application that is built into the graphing calculator. So we'll make use of that. The appropriate section of the graphing calculator manual is also here. I want you to be able to use all the technology you can to understand what's going on here. But most of the time, we'll be working longhand. As this is a majors course, we have a set of learning objectives for the major. We're going to do primarily homework settings and exams for this course. I'm still trying to work out what projects would be advisable. Maybe do the exams as remote take home instead of in class. I'm still trying to figure this out. This is my first time teaching this course. I've done these topics in several other courses for about 30 years. My first job was at Robert Morris, where 85% of the students were getting BSBA degrees. And so we taught a lot of mathematics and finance there. I did that for 6 years before I came to Seton Hill. A lot of this is boilerplate procedure. Please come to class. I have correlative evidence that coming to class improves grades. If you're not going to be here, let me know. Send me an email. Give me a call at this phone number. It'll convert your message to a voicemail and email it to me, and I'll have it right away with a timestamp on it. I will be taking attendance. The registrar's office has requested I use the attendance portal in Canvas. That tool doesn't have an excused button yet. It still marks people as absent, but then I can add a badge that says it was excused, and I'm not sure how it rectifies that, but the one in Canvas counts 0% towards your grade anywhere. It's just there for record keeping. I have a list of assigned homework problems. At this point, I have literally just written assigned problems. You'll notice that third column is mostly, the last column there is mostly blank. Right now, I think you should do all of them, but I really don't have a good judge of which ones are really important as to the exam structure themselves for the actuarial exams, not for my exams. But that means that some of these sections are like 16 problems and some of them are like 3. So there's going to be some back and forth on homework. Right now it's scheduled that each chapter is to be turned in as a group. If you want to turn in individual sections as we finish them early, that's fine. But on our Canvas page, the assignments section shows all of chapter 1 as being due 2 days after we finish the chapter. Here's our schedule. We're supposed to take 2 weeks to do chapter 1. So that stuff would be due on the 11th. And notice the first exam is only chapter 1. So you turn stuff in. I post keys. I have a review sheet for you. Here we go. And then we have an exam. So that's not what you need. That's what you need. So I'd like you to do as much of the homework as you can. I'd like you to come to me and talk to me about these things. I think doing the problems helps you understand this more than me flapping my face most of the time. We have to understand the terminology they're using. I don't know if we're going to get a tutor for this group, for this course, but as soon as I get one, I'll put information up on our Canvas page. Turned in assignments, please. I expect assignments on paper. I know it's horribly Luddite of me, but I want you to write this stuff out. Again, typing math is awkward, especially with the word symbols we're going to end up using. So I think it's easier to handwrite this stuff. You can write it on a tablet if you'd rather than use a piece of paper and just print it. That's fine. Perfectly okay with that. I've got 4 scheduled exams. We're going to use the graphing calculator a lot. Please let me know if you're going to miss an exam. I really think that's a bad idea, but let's say you're going to miss exam 2, you're coming up the road, you blew a tire, you email me, we'll work out a makeup. If you just blow off exam 2 and I don't hear from you, I don't know what's going on, we're not going to schedule a makeup and I'll double your exam 3. But that's a problem because each exam is 17% of your grade. And if I double one of them, that means one exam is 34% of your grade. No, that's a bad day. I don't want that much pressure on you. So ideally, you should take all 4 exams and spread everything out, as many bites as the apple as you can get at. You will not be allowed the internet during exams. That's why I want you to have your graphing calculator as a non-internet enabled device. And that way we can be sure that I'm getting what's coming out of your head. Here's a grading scale. If you get an 82 in this class, you are guaranteed a B minus. You might get a B. I don't know. I won't curve until after the final exam. No interim assignments are curved. No interim exam grades are curved. Only the final would be curved, if at all. Everything's done in Excel. The Canvas gradebook is usually within 1/100% of that, so that's pretty damn close, and rounded to the nearest whole number. The course is designed for face-to-face. I think you asking me questions and trying to clarify stuff will help both of us. And that way we'll get a better reaction than you just sitting here going, pour it in my head, man. That doesn't work very well, in my opinion. But I will record this. I will post everything. I'll say anything I write under this camera will get scanned and posted as well. There's a spot on our Canvas page down here at the bottom for the class scans. Once I have this first recording posted, under the web links section, this link will go live with a link to the YouTube playlist. I don't have the playlist until I have the first recording in it. That way I can get that in there. I've got a bunch of sample problems already written and typed up. So we're going to refer to these frequently. Back to the camera. Please make sure you keep the aisles clear in case we got to get out of here. The emergency exit's right here at the end of the hall, out, down, and across the street. You'll get starfish updates periodically throughout the semester. I'm required to give a couple of them, and when I think of particularly important things, I'll let you know through that. Your primary best contact for me is email. My email address is on that front page. Anything you call me about, if you leave a message, gets converted to email, please. But I'm an old man and I go to bed early, so you usually will get a response if you email me at 2 o'clock in the morning, the next morning. But I'm here early, so I tend to be responsive by about 7:30 in the morning. You give me at least 24 hours. Ideally, within 24 hours, every email will be responded to. You've got the schedule, you know what we're doing on any given day. I didn't break down the chapters by section very well because I don't know how long they're going to take individually. Some sections I think will go very quickly, but if that causes a stumbling block for you, I want to spend more time on it. I just said, well, do chapter 2, it should take about this long. That schedule is subject to change based on our pace. I don't have any extra credit assignments, but I may put bonus problems on homeworks or exams or something like that, and we'll make it work. Some of you will get it. Some of you will be staring at me like, what the is he talking about? If I'm going over something again and again, it's because somebody's still looking at me like I've hit them in the face with a fish, and I want to fix that. Make sure you put your valid email address in Canvas and Griffin Gate. By default, it's your Seton Hill email. If you set that up to forward somewhere else, that's fine. If I get an email from you, I will respond to it. But if I go to compose something to send to you, it'll go to your Seton Hill account. If I send something through Canvas, it'll go to your Seton Hill account by default. If you have that forwarded and respond through that, that's fine. That way I don't have to remember who's country butterfly 25 at yahoo.com. Please set your cell phone to silent or vibrate during class. I'm only asking for 50 minutes. If it goes off audibly, we all jump out of our seats. I'll answer it if it's an emergency. I'll give it to you, tell you to go take it. Otherwise, just take it if it rings, but ideally quietly. No tobacco use in the building. I had somebody knock over one of those spit cups in this room once, and we had to sand the entire floor. It was a disaster. Title IX. I am a mandatory Title IX responder. I am required by law to report any evidence or information about harassment, including sexual harassment, gender violence, all of those things. If you tell me something, I am required by law to respond to. Shouldn't stop you. If you don't want to talk to somebody who's not a mandatory responder, here are some options. I don't actually put any names on anything. If I can avoid it, you tell me about something, I go say, hey, a student in my class spoke to me about this, put that in an email, send it to the responder, to the coordinator, and please give me a call so I can discuss this with you. It's not in writing, it's a verbal report. If you are legally, if I'm legally required to give you accommodations for some reason, please contact Student Services, 5th admin, far end when you get out of the elevator by the end of next week, so I know what I should give you, what you are legally entitled to. You don't have to tell me why, but I'll get a notification through the system that says, so-and-so is legally accommodated to extra exam time, note takers, etc. Speaking of which, if you think you take particularly good notes and would like to volunteer to be a note taker for this course, please let me know, and I will ensure I do as much as I can to put you in contact with someone in case I do get an accommodation for notes. Academic engagement. As I said earlier, I think this class is best done as a discussion, best done as a understanding of what are the particularly weird pieces of notation that this textbook uses. And that means working more than just the 75 minutes we're in here. We meet 3 hours a week. There's an expectation that you should be working another 2 hours for every hour in here. That's another 6 hours. What does that look like? Well, that looks like a number of things depending on you and the way you study. It could be, I'm going to read this thing. Reading this textbook is non-trivial because this was written by somebody who knows this stuff cold. And they make references to events in financial history that are 40 years old. I had to go look some of these things up and go, what was that? I was alive during that time, but I don't remember any of that. I was 12. What are you talking about? All right. So some of this is going to be obvious. Some of this is going to be ancient history. It could be, I'm going to rewrite my notes because I was paying more attention to the discussion. I'll skip something in writing. Let me go back and listen to the video again and recoup that and write better notes. It could be, I'm going to start working on the homework problems. It could be, we're going to work together in a group and have a discussion about, well, how did you do this? That's fine. But if you think the 3 hours in here is going to be sufficient, I'm telling you right now, you don't. Academic honesty. Don't cheat. What does that mean? Well, I know for a fact that the solutions manual to this is a PDF. So you can find every one of these problems answers somewhere. You can get on Chegg, you can get on Google, you can write the problem in, you probably get about halfway through typing it before it'll autocomplete for you and show you the answer. Is that going to help? You have an answer. You know how they got it? You understand the process. Will that help you when you get here and are disconnected from the internet for the exam? Far less. So I advise you to work with each other. You notice it says non-sanctioned collaboration, plagiarism. Work with each other on understanding what's going on, using it as a last resort. Use the technology, use me, use the tutors. Let's get this to be a more direct behavior. Again, cheating's frowned upon. Please don't do it. What questions do you have for me about the way we're going to run this class? You look like you're completely enthused to be here at 8 o'clock in the morning. I'm awake, I promise. We'll make it work. Okay. While this starts as a discussion of investment and credit, that's what the textbook says. What this really is about is money. So I was tempted to start the entire course with a video clip that's older than all of us. The musical Cabaret has a song in it called Money Makes the World Go Round. And it's a wonderful song, but really, why do we have money? That's not a rhetorical question. What's the purpose of money? Say that again. Okay, Joe, you were going to give me some as well? Trade. To trade. Okay, but goods and services therefore have some sort of intrinsic value that I'm trading for, right? So why not just keep trading? That was what we did before, right? I walk into the market with my pile of stuff. You walk into the market with your pile of stuff. And I go, I'll give you some of this for some of that. And we're done. 2 eggs for a bag of sugar. Small bag of sugar. 2 chickens for a half a gallon of the milk that came out of your cow. The whole reason we have money is to avoid bartering. It's so that I don't have to bring all this stuff with me that I think you might want. I can instead create some agreed upon value. A couple of months ago, there was a shortage of eggs. Eggs were about $6 a dozen. I mean, it got to the point where the restaurants were saying, if you want an extra egg in your meal, it's going to cost you 50 cents per egg. So all of a sudden, we had a change in value because we had a scarcity issue. The goal is to avoid bartering, to avoid that sort of discrepancy in value. Ideally, that means that you and I would agree on the value of certain items. You might say, no egg is worth $6 a dozen. I'm not going to pay that. And so fewer people buy eggs and we end up with more of them. When you have more of them, the prices go down. That's the law of supply and demand. But that means I should have some common value. You have a laptop in front of you, which you got, I presume, from the school. How much is it worth? If you had to go buy that, what would you cost? What would it cost to you? Ballpark it. What do you think it costs? 1,000? Okay, it's about $1,000. You have $1,000 in your pocket. So if you go to buy this computer, you're in trouble, right? How do you get the computer if you don't have $1,000? I'm going to go buy a car. I don't have $15,000, $20,000 in my pocket. How do I get the car? Aha. I have to borrow money from somebody. So somebody has to have the money to give me. There's a lender and a borrower. Or I could say, no, I'm going to wait to buy the car. So I'm going to save some money. And okay, what happens? I take my money, I'm going to save it. I'm going to save up to buy this computer. It's going to cost me $1,000. I can do that. Save $100 a month. I'll have the computer in less than a year. What do I do with the money? Stuff it under my mattress? I have a jar on my dresser. It says computer fund. I keep stuffing $100 bills in it every month, right? Well, the money just sits there. If I have the $100 and somebody else happens to need that $100, I know I won't need it for a while. I could give it to them and say, yeah, you give it back to me when I need it. And then they have to pay for the privilege of using my money. I take out a loan. What happens?
You have to pay.
What's interest? The definition of interest is the privilege you pay to use someone else's money, or what someone pays you to use your money. Depending on which side of the equation you're on, it's either the price you pay to use someone else's money or the price that they pay to use yours. A lot of textbooks call this, because this really matters how long you use their money as well, we'll call this the time value of money. TVM for short. So in a sense, this course is about understanding TVM. So, who decides? Well, usually the lender decides how much you should pay to borrow the money from them. But sometimes you as a borrower can say, I'm only willing to pay this much, and then find out who's willing to lend you things. The US Federal Reserve Board, been in the news for the past couple of days, they set a rate on borrowing from the federal government. Now, they don't actually call it an interest rate, they call it a discount rate. Now, discount rate works a little differently. You want to borrow $100, let's say the discount rate is 3%. You're going to borrow that $100 from me. I'm only going to give you 97. Why 97? I took away 3%, right? So there's the discounting part. And I say maybe that 3% is for a month. Maybe that 3% is for a week. Maybe that 3% is for a year. But I can set that rate. And that's a target rate by which banks borrow money from the Federal Reserve. Now, this affects stock market, bond market, the general cost of borrowing to everybody else. Because if a bank wants to look, if you want to go borrow money from a bank, the bank has to have the money. If they don't, they have to go to someone and borrow it. That trickles all the way back to the Federal Reserve. So the Federal Reserve discount rate affects all of those things. And since everybody needs a cut along the way, those rates go up from the federal discount rate. The higher the interest rate is from the Fed, the lower everything else gets. Because if I can just make money by borrowing, there's no reason for me to put, or from lending, there's no reason for me to put money into risky investments like stocks or bonds. So those rates fluctuate inversely to one another. Even remarks by the Federal Reserve Board, the chairman of the Federal Reserve, can cause things to happen. If Jerome Powell, the current Federal Reserve Board chair, says something about potential changes to interest rates, the market will react. Sometimes he says interest rates might go down in the next 6 months. The market will get higher. Interest rates go down, the market value goes up, and vice versa. They're inverse to one another. Page 2 of the textbook has a remark from Alan Greenspan talking about the irrational exuberance of the market reacting to the chair's commentary. So all of these markets interconnect with one another, and they're related. 2003, yeah, 2008, page. This box talks about the housing crisis in 2008. What happened in 2008? Anybody know what happened to housing prices? I know, you were little. They crashed horribly. Housing had been going up and up and up and up and up. And suddenly, people went from having a $600,000 house to that house being valued at $200,000. I mean, there was a huge crash. But what happened in addition to that is interest rates tanked substantially. Here are some interest rates based on time. These are all Novembers. November of 1992, the Federal Reserve target rate. The prime rate is the rate that banks lend to their most preferred customers. LIBOR, this is an abbreviation, London Interbank Overnight Rate. The way banks lend money to each other overnight. Remember, I said if the bank doesn't have money, they have to borrow it from somebody. They borrowed for literally overnight. The overnight rate was based on the federal target rate and related to the prime rate. Bond rates, high yield bonds, mortgage rates. These are loans. So we've got a fixed rate 15-year mortgage, 30-year mortgage. ARM stands for adjustable rate mortgage. And down here at the bottom, we have treasury bills. Treasury bills are loans from the US government. You give them money, they will pay this amount. Notice it's calculated as a discount rate. We'll work on all what these mean as we go on. But notice, 1992, 2007, just before that housing crash. What the hell? 4% interest rates, 1.16% interest rates. 0.08. We're not charging interest to borrow money. We're basically throwing money at people. You borrow $10,000, you'll pay $8 in interest. Hell, I'd borrow money out the wazoo. Why did this happen? What happened during COVID? Money stopped moving. How do you make people move money again? You make it cheaper and cheaper for them to borrow it and spend it. So our interest, and we've been creeping back up ever since. So there's been a lot of change. All of these terms will have to be defined for us to understand what's going on. Okay. What's an interest rate mean? If I think of this rate, well, that's the amount extra I'm going to charge you to borrow the money. So it's going to be how much interest is charged divided by the loan amount. It's almost always expressed as a percentage. And once I have that rate, we actually usually think of interest itself as a value, and the loan amount is called the principal. So we'll get a rate, and it'll be the interest divided by principal. We'll go it the other way. Interest itself is principal times rate. It would be more convenient to then work something into this about the time we're going to work in. So frequently, we'll take this and adjust for time. Maybe that's rate per year, or rate per month, or rate per week. In that case, we're going to need to insert here number of time periods. Now, when written like this is simple interest. But most of the universe doesn't use simple interest, unfortunately, particularly for longer periods of time. And this is where we actually have to work on the time part a little more closely. When I look at how interest is dealt with, the assumption is that when I put interest in your hands, I don't physically give it to you. I put it in the account where the principal is residing. So let's use this like it's a savings account. You put $2,000 in the bank. You put $100 in the bank. We'll figure it out. The number itself is irrelevant. If I put $2,000 in the bank, let's say right now, interest rate's about, I don't know, 7%. How much is the bank at the end of the year? It is January 1, ching, there goes my $2,000 into the bank. December 31st rolls around, and the bank goes, here's your interest. How much do I have? Calculate. What did you do? That's a discount rate, right? You took the money away. This says interest rate, right? I'm adding this on instead of taking it away. So instead of multiplying by 0.93, I want to go the other way and multiply by 1.07. So I want to say, oh, I've earned interest of $140. And if I add that to my principal, I've earned 2140 instead of going the other way and subtracting. Now I can also think of this formulaically as saying, oh, I took the $2,000 multiplied by 1.07, 1 plus my rate, and that result is the same thing. Now, I don't need the money yet. A year has gone by and I don't need to spend this money, so I'm going to leave it. Another year goes by. What happens?
The interest is just on the initial loan.
Ah. The interest is on what's in my account. If I stick that $140 interest into the account, then it should earn interest as well, shouldn't it? If instead that $140 went in your pocket, then yeah, there would still be $2,000 in the account and I'd earn another $140. But since I left the 140 in there as well, the whole thing should earn interest. Okay, now I'm going to make more money. Not a lot more money, but I'm going to make more money. Rather than making $140, I make
$22.90.
give it to me all the way out to pennies.
$289.
Now, wait a second. In terms of the original amount, that 2140 came from that line above, right? That's from here. So if I replace this number 2140 with this expression, this is 2000, 1.07, and then another 1.07, that's 2000, 1.07 squared. I multiplied by this interest factor, this 1.07, a second time. If another year goes by, what's going to happen? It's going to be Q. Hey, wait a second. This is not simple interest because I'm computing my interest at multiple points throughout the time period. This is called compound interest. And our accumulated amount can be computed by looking at the principal, the present value, rate, number of periods. So if I left this money for 4 years, what would I end up with? 2621
59.
What's the third decimal place?
Yeah.
Okay. Interestingly enough, that third decimal place, that fraction of a cent, matters in a lot of weird ways. More on that later. Depending on where you round and how you round, that last digit can matter quite a bit. On page 7, you'll see a sequence of interest charges written as a timeline. This time diagram, figure 1.3, shows an n period set of deposits. Time goes from left to right. We deposited. We had an interest payment. So here's our accumulated value. We had another interest payment because this much was in the bank. It earns interest. We add that on. There's our square. Keep going. We end up eventually with an accumulated value, 1 plus I to the n. Now this assumes a deposit value of C. Current value, yes. It depends on how we look at it. There's another example on the previous page that deals with $1,000 investment at 9%. I like that. That formula for compound interest, that's one of the most important formulas we're going to see this whole semester. And we've got it. We haven't even been at this an hour yet. But there's a massive assumption made in this example we just did. What massive assumption did I make? And we saw with that list of rates earlier that over time my rate changes. So the problem here is that the interest rate was constant. That isn't always a guarantee. So what if my interest rate changes? So if that's the case, then ideally we would have a fixed interest rate per period, right? If the interest rate changes every year, then I could do this calculation with a new interest rate in each year. If the interest rate changes every month, I'm going to have a little more problematic of an issue, right? I'll have to make my periods months instead of years. The interest rate changes every day, I'm in deep shit. And this is going to be a real computer problem at that point. But let's run with the assumption that the interest rate is constant per period. So maybe that's 7% this year, 8% next year, 6% the year after, 5% the year after that, whatever. Well, then each one of these multiplications could be different. So I can't use a single exponential. What I will have is a giant product. Every time I multiply, I might be multiplying by something different. This will be our accumulated value A. And then each of these numbers is a growth factor. I would really prefer to then take this and kind of figure out, all right, well, how'd I do on average? Right? Because that would make more sense to me. What's the average rate over this whole time? Hmm. Let's do an example. See if I can figure this out via an example. Instead of calling it an interest rate, when I think of something like a market fund or a stock fund, we call them a rate of return. So I had a plus 10% year, a minus 12% year, a plus 90% year. Holy crap, something really good happened. Followed by a minus 30% year, and then a plus 25% year. If I think of this instead of 5 1-year blocks as 1 5-year block, how did I do over the last 5 years? I'm going to make my life easy for a moment. Let's just assume that I had an investment of one. One what? I don't care. One. $1, $1,000, $1,000,000. Doesn't matter. I want an investment of one. How much should I end up with? The end of 5 years. Go through those interest rates. How do I figure this out? Well, that's exactly the formula that just rolled off the top of the screen here, where n is 5. Tell me what you get. How did you get that? That's unfortunately not what our formula up there tells us to do, Maria. I've got to do this multiplication sequence to figure out what's going on, right? My investment of $1 will have earned a future value of 1.10 times 1 minus 0.12 times 1 plus 0.9 times 1 minus 0.3 times 1 plus 0.25. So that's 1.10 times 0.88 times 1.90 times 0.70 times 1.25. Because this is a multiplicative procedure at each step. What's this value? Great. However, that's over 5 years, right? So I made 61 cents on a dollar. I made $6,093 on a $10,000 investment. I made a bunch of money here over 5 years. What did I make per year on average. Again, how did you get that? Wait a minute. I multiply, right? I multiplied something 5 times. If the rate was constant atom like we did in the example, I would have had 1 and then 1 plus R, right? But I've done 5 years. So if I did it at a constant rate, what goes up here? Aha. So if that's my 5 year at a constant rate, this should be equal to this. So I don't want you to divide, I want you to take a root. There is no fifth root button on the calculator. There are 2 different ways to do this. You could raise it to the 1/5, or you could use the nth root button, which is hiding under the math pile. Math, there's a root with an X in front of it, so you can compute it that way. So you can go, I want the 5th root of 1.6093. Which really tells me I made just shy of 10% a year. The other way to do this is 1.6093 raised to the 1/5. You could use decimals and raise it to the 0.2 if you wanted. Depending on the application, some people prefer to use 4 decimal places, some use 5 or 6, some use 7 or 8, depending on what you're looking at. Some bond rates keep 6 decimal places. Some bond rates keep 6 decimal places after moving over 2, which means they would use 8 here. In the interim calculations, until we get to the end, keep all the decimals your calculator offers and wait until the end to do any sort of rounding. I think that's easier. Questions? I know you're taking a problem stats course. I've seen this before. Multiply a bunch of numbers and then take the root based on how many there were, right? We multiplied these 5 numbers together and then took a 5th root. That's the multiplicative version of an average. That's the geometric mean. There's another example in the text on page 7 through page 8 that goes through another version of this as well. But what this is now an annualized rate. I like this idea. I think I want to use it some more. Questions? regardless of whether I compute interest at different rates over different times, or even at the same rate, I might want to do it more than once a year. My credit cards compute their interest monthly. My deposit account with TIAA CREF, my 401k, computes its interest quarterly. So depending on where you are, some interest rates are charged far more often. A number of payday lenders charge interest by the week. So how do I figure out a relatively uniform standard? I like this idea where we converted different rates to a year. But if I had, say, a rate that was based on weeks, or a rate that was based on months, or a rate that was based on quarters, then I can think about that as a different variable, J in this case. And then we'll have a number of periods a year. The effective annual rate is the rate that J would be equivalent to if I only did one compounding per year. So how do I figure this out? Let's suppose, like my credit cards or like my mortgage or something like that, something that works on a monthly basis, I'm getting charged 1% a month. What is the effective rate per year here? At the end of 1 year, how many times have I computed the interest with J? 12 times, right? So my investment of 1, again, just to make my life easy, that much. Which is how much? Let's give me some more decimals. Let's go with 4 decimals. 1,
1268.
so if I waited until December 31st before giving you any interest, I'd have to use this rate. to make it match what it would have been if I paid you interest all along, right? Aha. So this is what I would do at 1 year rather than doing this every month. So these are equivalent. They result in the same amount of earnings. Subtract the one off. Instead of using it as a growth factor, I use it as the actual rate. And then I see that this rate effectively is 12.68% a year. It is almost always more useful to compare a rate with an equivalent time period. By law, the Truth in Lending Act, Truth in Savings Acts require us to be given annual effective rates. Textbook definition says two rates are equivalent if they result in the same accumulated value at each point in time. So here are some weird questions. Which of the following is better? A rate that lasts 17 days at 0.75%, or a rate that lasts 67 days at 3%. You got a choice. Your choice. How do you want to figure each point in time? We can calculate an effective rate for any length of time. We could calculate an effective rate per day. We could calculate an effective rate per year. Like I said, the law requires us to be given the effective annual rate, but that doesn't mean that might not be the rate we actually use in practice. As a matter of fact, if you have a credit card, you should, if you can find it, get the agreement for that credit card. You should get one every year, even if it's just a card for a gas station. You should get an agreement for that credit card once a year. And it should tell you how they calculate interest. And it should tell you what effective rate they use. They might not actually use the annual rate to calculate your interest. Most credit cards use a daily rate. I want to turn these into daily rates. How do I do that? Right, because I know that 1 plus R to the 17th should be equal to 1 plus 0.0075, right? 3/4 of a percent. So I can say that R is 1.0075 to the 1/17th minus 1. I don't even have to do the minus 1 part if you don't want to, because I'm going to compare it to the other one, right? And whether I add the ones or not, I can write that down. So somebody give me a number. What is this? You're probably going to need at least 5 decimal places for this, but you might as well write down every decimal place your calculator gives you. It's only like 8.
There's one.
Your call.
Okay. It's 1.0004396. 27.
Great. You'll notice you said 1. I had already written down minus 1, so I just took it off anyway. Still works. Let's do the other one. The other one is going to require a 1/67th power. 1 plus R to the 67 equals 1.03. So R is 1.03 to the 1/67 minus 1.
0.00044.
I know this one's going to be bigger, right? Just a tiny bit, but it's going to be bigger. Again, more decimal places, 441273, right? This is the bigger one. That's a better one.
So when we do these exercises, are we looking at the rate as the loaners?
Well, that's a good question, because if I look at it as a borrower, I want the other one, right? I believe the question asks which one results in more rapid growth. This one will grow faster because it's a bigger rate. Whether I'm the borrower or the lender, that's faster growth. By the way, if I double both these rates, do you think this will change? If I change that from 17 at 3/4 to 17 at 1.5, and I change 67 from 3 to 6, you think that would change anything? Guess what? It does. If we do the exact same calculations here, we get 1.015 to the 1/17 minus 1 and 1.06 to the 1/67 minus 1. Need at least 6 decimal places.
0.00876.
And when I do this one,
0, 0, 0. 8, 7, 0.
If I double the numbers, it changes which one grows faster. Because I didn't double the periods the same way. I didn't change those. My compounding factor matters. That's why I need agreement in time to understand these calculations better. By the way, we did daily rate. How could I do this to annual rate? What if I wanted an annual instead? Oh. Well, then I'd be doing that for 365 days, right? That's a year. So instead of taking this route, the 1/17th, I get the number per day and then raise it to the number of days. So I could do this same calculation, 1.015 to the 365 over 17, and 1.06 to the 365 over 67. You're going to get very different numbers, but the same one should be larger, depending on which version you do. Somewhere, if I actually had a credit card that did this, somewhere in there, these numbers would have to show up. By law, they're even required to be boldface. But that's the Sarbanes-Oxley Act. Came about in the late 90s, early 2000s. So it's been a fairly substantial change to the way in which lending was communicated to people. Yes, ma'am.
So if we had doubled the periods, the same one would have been larger?
If we doubled the rates and the periods, yes.
Well,
If we double the period only, it should still be the same.
Oh.
But if we double, because that would change the exponents in the same proportion, right? It is we don't have a good intuitive understanding of exponential behavior. I get linear behavior. I even get quadratic behavior pretty well, but there isn't a good intuitive understanding of exponents. It's much less obvious. You'll notice I didn't say anything about the number of deposits or how much we were depositing. Because this was a rate-only calculation, I just said I'm going to deposit one, make my life easy. But if I have multiple deposits, or I have a sequence of deposits, some withdrawals in a particular account, it's a little more difficult to do one fell swoop calculations. On page 10, here in example 3, they show a sequence of deposits and withdrawals at a bunch of different times. And rather than work out one calculation, it's like, oh, well, let's just, every time we do something, let's calculate what's still in there and then work the interest forward from that. As a matter of fact, here is our timeline idea. But notice what we do here is we have this and we say, oh, I'm going to bring that all the way to the end. I have this, I'm going to bring it all the way to the end, and I'm going to add and subtract once at the end. This is really a one fell swoop calculation. But you have to know exactly when every single transaction is going to be done, right? If you don't have them all pre-planned out, this is usually easier. Most credit cards, most loans, most mortgages use this form of calculation. Your bank account works this way. So this is more realistic. But this is a better planning idea. So we will continue this discussion on Thursday, right? 75 minutes, 8 to 9:15. Thank you all very much. I am going to be over in the Enrichment Center in about another 15 minutes to pack all this, and then I will see you all there. My recording will be up. The link will be live probably in about an hour, as well as all of these scans will be on our Canvas page. Have a wonderful day.